the quadratic formula. At this point, we can solve any quadratic equation we're given using a handful of different methods. The first method we always check to see if we can use is the extracting the roots method. If that doesn't work, we check to see if we can solve by factoring. And if that doesn't work, we can solve by completing the square. Completing the square method, as we said, does always work, but it is a pretty long, drawn-out method. So somebody came up with the idea way back when and thought, well, if we complete the square on the general quadratic equation, ax squared plus bx plus c, go through all the steps of completing the square, then all we would have to do is substitute in the corresponding values for a, b, and c in order to solve each individual quadratic equation. So that's what we'll go ahead and do. The first step in completing the square, make sure a is equal to 1. Now a can be equal to anything, and make sure it's equal to 1. We're going to divide everything by a, giving us x squared plus b over ax plus c over a is still equal to 0. Now we're going to move the constant over to the right hand side. So subtract c over a from both sides. And off to the side of our paper, compute 1/2 b squared. Keeping in mind that b is now b over a, so b over 2a squared gives us b squared over 4a squared. So add b squared over 4a squared to both sides of the equation. And that makes the left-hand side factor into a binomial squared, which is, in this case, going to be x plus b over 2a squared is equal to the right-hand simplify. Well, of course, we need to come up with common denominators, which is just going to be 4a squared. So we're going to multiply c over a, the numerator and denominator, by 4a, which gives us 4a squared in the denominator, 4ac in the numerator. So now we combine them. We still can't combine the numerator, so we'll just write it b squared minus 4ac. The denominator is, of course, 4a squared. Now our only x is being squared, so continue solving by extracting the roots, square root of both sides, not forgetting your plus or minus. X plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 2a. Solve for x, subtract b over 2a from both sides, which gives us two fractions already having common denominator, so we can combine them. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a, which, as y'all have seen before, is the quadratic formula. Most of y'all have seen it, have used it before, but probably have not been shown where it comes from, or this is where it came from. No one just dreamt it up one night saying, I think this formula will solve quadratic equations. It was solved by completing the square on the general quadratic equation, ax squared plus bx plus c. So now all the steps of completing the square have been done. The equation is solved for the variable x, so all we'd have to do is substitute in the corresponding values for a, b, and c from the quadratic equation and simplify. Now, you're probably just going to have the quadratic formula memorized instead of deriving it each time you need to use it. And it's still not the quickest method to use in order to solve a quadratic, so we still want to rely on extracting the roots and factoring. But the quadratic formula basically takes the place of actually having to go through and solve by completing the square each time. So example 1, we cannot solve by extracting the roots. We can solve this equation by factoring. It factors into x plus 4, x plus 7 is equal to 0, giving us two solutions, negative 4 and negative 7. But we'll solve it again using this quadratic formula. So going back to the original problem, a is equal to 1, b is equal to 11, c is equal to 28. Now we know in order to complete the square, a must be equal to 1, but we've already completed the square, so there's no restrictions on a, b, or c. Just substitute these values into the formula, not forgetting your x equals, that's what we're solving for. And anytime you substitute a value in, I strongly recommend you do it in parentheses to reduce the chance of making careless mistakes. Now just a matter of simplifying. Follow the order of operations inside the radical. That exponent first, 11 squared gives us 121. Negative 4 times 1 times 28, negative 112. So the entire radical simplifies to just 9 all over. It should be 2 times 1. So now simplify a little further. Negative 11 plus or minus the square root of 9, which is 3, all over 2. Which gives us two solutions, negative 11 plus 3 over 2, which simplifies to negative 8 over 2, or negative 4. Negative 11 minus 3 over 2, negative 14 over 2, or negative 7. So obviously same two solutions that we came up with by factoring, but we still see factoring is still much quicker. But this quadratic formula does always work. So let's look at another one. Example 2, quadratic equation. Begin by putting it in standard form. X squared plus 8x minus 12 is equal to 0. Extracting the roots would not work. Factoring would not work either. So completing the square, or this new quadratic formula, using the quadratic formula, a is equal to 1, b is equal to 8, c is equal to negative 12. So substitute these values in. Negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 12 all over 2 times 1. Simplify. Negative 8 plus or minus the square root. That radicand simplifies to 112 all over 2. Simplify that radical even further. Negative 8 plus or minus 4 times the square root of 7 all over 2. So we cannot combine the two terms in the numerator in this case. In most cases, most examples, we will not be able to, but we still have a fraction, two terms in the numerator, one term in the denominator, so we have to see if we can reduce this fraction, and we certainly can. 8, 4, and 2 are all divisible by 2, so negative 4 plus or minus 2 square root of 7. Which obviously, once again, two solutions, negative 4 plus 2 times the square root of 7, negative 4 minus 2 times the square root of 7. So quadratic formula, which brings us to something called the discriminant. The discriminant is a number that is determined by a formula, b squared minus 4ac, notice the radicand of the quadratic formula, that we can analyze, and it'll tell us how many and what type solutions a quadratic equation will have without actually having to go through and solve it. So you find the discriminant using the formula here, b squared minus 4ac. Then you're looking to see if it's positive, negative, or 0. If it's a positive number, you know that quadratic equation will have two real number solutions. If it's equal to 0, there's only going to be one real number solution. And if it's a negative number, there's going to be two non-real solutions. In other words, two complex or imaginary solutions. So example 1, find the discriminant of this quadratic equation. Notice we're not asked to solve it, just find the discriminant. A is equal to 1, b is equal to negative 5, c is equal to negative 9, so just substitute those values into the formula. Negative 5 squared times 4 times negative 9, and simplify, works out to be 61. The 61 isn't the important part of the discriminant. The fact that it's a positive number, positive 61, tells us there's going to be two real solutions to this equation if we were to solve it. Example 2, the same thing. Begin by putting it in standard form so we can identify the values for a, b, and c. Substitute those values into the formula for the discriminant. Negative 9 squared minus 4 times 1 times 21 simplifies to negative 3. And the fact that it's negative means there's going to be two imaginary or complex solutions, or non-real solutions, however way you want to state it.